Okay, well, notice this angle A, and notice that this little segment here is parallel to this little segment, well, not little, this big segment here is parallel to this little segment right here. And this angle is A. Well, we have an alternate interior angle right here. If you can see where my arrow is, that angle is also A, so I'll just label that as A. If this angle is A and this full angle is 90 degrees, then this angle must be 90 minus A. And then if you look at this triangle right here, this is 90, this is 90 minus A. We now know what this angle is up here. That angle is also A. Okay, so it turns out this angle up here is the same as this angle down here. So let's focus on this triangle right now. It's got a hypotenuse sine B, and my angle is A. We're using the same trick that we've been using before to get like this side and this side and this side. Here's the hypotenuse, here's the angle, this is the adjacent side. So I know that this side is sine of B cosine of A. That's this side from here right to here. Well, we also know what the length of this line segment is. That one's a tough one to label. I'm just going to put it over here. That's the hypotenuse times the sine of the angle. I'll draw a little arrow there so we know what that is. There we go. That was the length of this right here. Sine B sine A is the length of this side. Well, we're actually just about ready to give our proof. We're basically done. One thing to notice is that what is the length of this big segment right here? Well, if you see this triangle, right, here's the three sides, right, like that. It has a hypotenuse of 1, an angle of A plus B. The length of this side must be sine of A plus B, which is what we want. Right? This angle is A plus B, hypotenuse of 1. The length of this long line here must be sine of A plus B. But we've already broken up this tall thing into a little piece here, given by this, and a piece here, given by this. We can simply add sine B cosine A, cosine B sine A, and we're going to get our formula. Now typically these are written a little bit differently. So I'm going to start with this one first and just reverse the order there. So I get sine of A cosine of B, okay, plus this line segment, which is sine of B cosine of A. We've just proved our first formula. Now how do I get cosine of A plus B? Well, again, big triangle, hypotenuse 1, cosine of A plus B is the length of the line segment from here to here, right? Because that's the leg of this big triangle with a hypotenuse of 1. Well, I can just take this entire length and then subtract this little length, which is the same as this, which is this. Okay, hopefully you're following that. So the answer here is cosine of A, cosine of B. That's this length. I just flipped the order. Doesn't make any difference. Then I need to subtract this one right here. And again, I'll just put it in a different order. Sine of A, sine of B. And there we go. We've just proven these two formulas. Hope you enjoyed this video proof.